Hey guys, so I'm still in section 4.2, so we're continuing on. Let's see, I'm on page 347 here. So at this point now we've learned quite a bit about lines, and one thing we've probably noticed is that there are certain lines where it's easier to find points for them than others. And so now I actually want to kind of classify that. So for now, there are really two types of lines that we're going to discuss. Sorry about that. There are two types of lines that we're going to think of. So the first one is the slope-intercept form. So this is y equals mx plus b. So b stands for the y-intercept, and it's of this form 0b, and then m stands for the slope. So this is one form of a line. The other form of a line is the standard form, so you let a, b, and c, for our course, these are going to be integers. A and b can't be 0. So here's the standard form of a line in that case. So here's the thing that I want to start with. Moving on to this example, I just want to get you used to identifying which form that you're in. So for instance, with this first one, is this a slope-intercept form or standard form? This would be in standard form. Versus B, B is in slope-intercept form. And then maybe pause and choose what C and D are if you need to. So C, even though it's in A and B, this is still in a slope-intercept form versus D is in standard form. So there's kind of like the idea between the two. So I really want to try to understand this. And one skill that's really handy to have is to be able to transform one form of a line into another form. So let's start with how do you transform an equation into the slope-intercept form. So remember, the slope-intercept form is just y equals mx plus b. So the solution for how to do this is actually right in the form of this. Basically, look at what's isolated. The y is isolated, so basically all you have to do is solve for y. So basically you have to solve for y, and you maybe have to ensure that like terms are collected, but honestly, if you're just solving for y in a formula, you're probably good to go. So we want to convert the following equations into slope-intercept form. So I'll show you how to do this, and then I'll have you do one. So let's say I have something like 2x plus 3y equals 6. So this is really just a formula, and so I'm going to go through and solve it for y. So I have to isolate this 3y. So to do that, first I have to subtract off the 2x. So I subtract off the 2x, and now I get 3y equals negative 2x plus 6. And then I can divide each side by 3. And so then those 3's will drop out, so I'm left with y equals negative 2/3 x plus 2. So that's basically all you have to do if you want to get something into slope-intercept form. Just go through the work to solve for y. So why don't you guys maybe try this one? So why don't we do negative 2x plus 5 plus 5y, equals negative 10. Pause the video, try that, hit play when you're ready to see the solution. So in this case, so the first thing I want to do is I want to add the 2x to each side. So I get 5y equals 2x minus 10. And then I can just divide each side by 5. So this becomes 2/5 x minus 2. And now that would be in slope-intercept form. So now what about if we want to go into the standard form? So there's totally times where we're also going to want to go in the standard form. This can be a little bit trickier. So what I want to do is I want to show you how to put two equations into the standard form just to get you a sense of it. So first let's start with just kind of the basic idea. So this is the first equation. So I'm going to use the equation, how about y equals negative 2x plus 3. So I want to put this equation now into standard form. Now remember what the standard form is. It's ax plus by equals c, and a, b, and c have to be integers. Now, if you look at this form of the equation, just kind of notice x and y are on the same side. That's kind of like the big thing you need for standard form. So in this case, I really just need to get x and y on the same side. So I'll just note that, get x and y on the same side. So to do that, I need to add the 2x to each side. So I get 2x plus y equals 3. And then is this in standard form? Yeah, it totally is, right? So this is already standard form, so we're done. So this is like the ideal scenario, but I'll warn you, it does not always turn out this easy. So I want to show you also kind of the more complicated example. So when you need to clear fractions. Okay, so let me just jump into this now. So now let's say that I've got something like y equals negative 2/3 x plus 4. Okay, so I still want to get x and y on the same side. So to start this, what I'm going to do is I'm going to go ahead and add 2/3 x to each side. So now look what I've got. I've got 2/3 x plus y equals 4. Now there's a problem here though, right? So if I go back to my definition of standard form, so all the way up here, the thing is that a, b, and c have to be integers. And so 2/3 is not an integer. It is a fraction, it is a rational. So this is the problem. So basically you can't have fractions with standard form. So you have to clear the fractions by multiplying by the LCD. So in this case, the LCD is nice and straightforward. It's just 3. So I'll go ahead and just note that. So here my LCD is 3. So I want to multiply everything in this equation then by 3, and make sure you do multiply everything. Now when you do this, we know that the 3's are going to drop out. We saw that in earlier videos. So this becomes 2x plus 3y equals 12, and now I have the standard form. So that's kind of the idea behind this. So here's what I want to do now. I want to have you just practice this a little bit. So I have on this page, let's just start with A and B. So just work to do whatever you have to do to get these two equations in standard form, and hit play when you're ready. So here for A, so I've got this equation. So I really just need to get x and y on the same side. So this just becomes negative 3x plus y equals negative 5. And then we're really done, right? That's all we have to do. We don't have to do anything else. Okay, now B. Notice with B, we are almost in standard form, except we have these darn fractions. So I have to find the LCD of all fractions. So the LCD of all my fractions would be 6. And so now I'm just going to make this nice and clear what I'm doing. So I'm going to multiply each fraction by 6 as shown. And I have to also multiply this last number by 6 as well. So that's the biggest thing. You have to multiply everything, right? Now, when I go through and I do this, 3 goes into 6 2 times, right? So the denominator will divide into this. So I'm just left with this first part. This is 2 times 1y. So this first part here, this is just 2y. So this is 2y. Now moving on to the next part. 2 divides into 6 how many times? 2 divides into 6 3 times. So then I have 3 times 1x, so that's going to be 3x. And then 6 times negative 4 is negative 24. Now if we want to be a stickler about format, x is supposed to come first, so this would be the best standard form we can come up with, if you will. Okay, so now what I want to do is I just want to do 2 more examples of this. Now I want you to get these 2 in slope-intercept form. Go ahead and do that, hit play when you're ready to see the answers. So in this case, so I've got 3x minus 2y equals 4. First I'll start by subtracting off the 3x. So I get negative 2y equals negative 3x plus 4. And then I can divide each side by negative 2. So I get y equals 3 over 2x minus 2. So that would be my answer in this case. Okay, so now let's take a look at the other one. So let's see. I've got negative 2x minus 6y equals negative 12. So I'm going to work to get the y by itself. So I'll add the 2x to each side. So I get negative 6y equals, we'll say this is 2x minus 12. And now I'll divide each part by negative 6. So just be careful with your signs here. This is y equals negative 1/3 x plus 2. Double check your signs. Okay, so this seems like a good spot to leave us off on, so I'll see you guys in the next part, which will also be the final part.